So welcome back to the Runtime error. Here we will be discussing one of the questions from Leetcode interview series, that is remove duplicate from sorted array. So what does question says that we will be giving one array which is sorted in itself, right? It is sorted though it contains duplicate elements, but it is sorted in itself as you can see over here. And what we need to do is we need to remove the duplicates, which means 0 is occurring twice, we need only once. 1 is occurring thrice, we need it only once. 2 is occurring twice, we need only once. So 3 is twice, need once, and 4 is 1, okay, 1 itself. So I hope so you understand the meaning of question. We need to simply remove the duplicates, but at the same time, after removing the duplicates, my final answer must also be a sorted one, must also be the sorted one. Now, as I told you that the first solution, as usual, that comes in our mind is brute force solution. Brute force solution. Now, as a brute force solution, what can we think on this problem? Is there any kind of a data structure? Is there any kind of data structures which keeps the elements in sorted order, and also does not allows duplicates? Is there any kind of data structures where we can use for this? Of course, yes. Can we say there is a data structure called as a set which keeps the data in sorted form and also does not allows a duplicate, So can we use the set over here? So simply what I will do is, say for example this is my set, I will simply declare this set and I will put all the elements of my array inside this set. So if I try to put all the elements inside this set, what it would be? So it would go 0. Now again I will come to 0, but the point is 0 is already present, so it will not get insert. Then I come to 1. Is the 1 my present? No, so simply 1 will go. Now again I come 1, but the 1 is already present. 1 again it is present. Now it comes 2. Is the 2 my present? No, so simply put as 2. Now again I come to 2, but 2 is already present. I come to 3. Do I have the 3 in my set? No, so I will simply put 3. Now again I come to 3. Now check, is there any 3? Yes, my set contains 3, so ignore it. Now I come to 4. Is there any 4? No, so I will simply put as 4. Now what I do is, again I will take all these elements in my vector. So my final answer would be 0, 1, 2, 3 and 4. So this is the answer I was looking for. Can I say yes? So let's write a brute force solution for this. So I am declaring a set which is of type integer data type. I am using a C++ language over here. So I will iterate through my vector. So this will be the for each. You know that for each for loop. So say for example my array name is ARR. So simply what I will do is I will simply insert all the elements inside my set. Now again what I will do is, again I will traverse my set. Say for example again IT, and this is set, and what I will do is I will push all the elements in my final array. Say for example as IT, and simply I will return my final answer, that is answer, which is also a vector. So this is my brute force solution. Now if you talk about its time complexity, what it would be time complexity. Now we know that the set internally work in self balanced binary tree, right? Binary tree, and in self balanced binary tree, insertion takes place in big O of log n time for single element, for one element. But the point is, here we are trying to enter n elements. So inserting elements inside my set will take big O of n log n. Now again I am traversing my set, so it will take big O of n time. So what would be my final time complexity? Can I say big O of n log n plus big O of n, right? Now what about the space complexity? Let's discuss the space complexity. I need to use a set, and in worst case there is no any duplicate element in my array. Say for example my array itself is 1, 2, 3, 4. Now I need to enter all my array elements inside my set. So can I say set is of size big O of n in my worst case? Of course yes. Now again I am declaring the vector to store my final answer. So again, can I say it would be big of n? So this is my final time complexity and space complexity. But is it a good solution? We are using 2 extra spaces, it is taking n log n time to insert element, again takes big of n time to put all the elements in my final answer. No. So we need a better solution. Can we do it something better than this? So let's discuss our final solution, that is called as an optimal solution. Optimal solution. Now we have given an example that is called 0 0 1 1 1. We got 2, we got 3, we got 3 and 4. And what we try to do is we will try to keep the answers in the same array itself, in the same array itself. We will try to do this without using one extra space. So let's check how can we do it. Say for example, these as indexes. Now I will check, do I need to check the elements present at the first position? Do I need to check the position element at the first position? Absolutely no, because of course this will be the first element that I really needed. Then I come over at my second position, I check, is there any 0 already I visited? Is there any 0 already visited? Yes, so I need to simply omit this. Then I come to 1, is there any 1 I visited? Is there any 1 I visited before this? No, so I need to take this. Now I come to this position. Now again I check, was there any 1 or I already visited? Yes, there is already 1. Again I come over here, I check, was there any 1 already visited? Yes, it was there. Now come to 2, was there any 2 already visited in this? No, so we take it. Then comes to 3, was there any 3 so far? No, so we take it. Then again we come at 3, but 3 was already visited, so we ignore it. And we come at 4, since there was no 4, so we take it. So I hope you are getting something what I am trying to say is. So what I will do is I will keep one extra pointer. So say for example, its name is index, which is initially at 0, that is pointing to this position. Now I will start our thing from this position 1. Now I will check if my this element is greater than its previous, this element is my greater than its previous, which means that element does not occur. For example, 0. Is the 0 greater than the previous 0? No. Therefore, hence it is duplicate. Now I come at 1. Is the 1 greater than its previous? Yes. So I need to take it 1. Again I come over here. Is this 1 greater than its previous? No. So ignore this. Again I come over here. Is this 1 greater than its previous? No, so ignore this. Then I comes 2. Is this 2 greater than its previous? Absolutely yes, so include it. 3. Is my 3 greater than its previous? Absolutely yes, take it. This 3 is it greater than its previous? No, ignore it. 4. Is it greater than its previous? Yes, ignore it. So I hope so what I am trying to do is. Now let's implement it. Say for example, I am running loop from first, right? It will go till n and n I plus plus. Now what I will do is I need to check if my a of I is greater than a of I minus 1, right? If this is greater than its previous, which means that element has occurred only once. But the point is, say for example, my index initially is pointing at this position, right? Now I come over here. Is my 0 greater than its previous? No, so ignore it. Then I come over here. Is my 1 greater than its previous? Yes. Now the point is, I need to insert this 1 at this position. I need to insert this 1 at this position. How can I put it? So this is the reason why I am making the use of one extra pointer called as an index. So that index will be the position where elements will be placed. So 1 will come over here and index will be shifted to this position. Now again I come 1. Is the 1 is greater than its previous? No. This 1 is not greater than previous. Now 2 is greater than its previous. But the point is, I need to insert this 2. I need to insert this 2 at this location. So this is the reason why I am using an extra pointer index to make sure the correct position of that element. So what I will do is, if this condition is true, I will simply put it as a of index equals to a of I, and at the same time I am updating my index value as well, so that I can insert the element in the next position. So this is my final answer. So let's try to traverse the algorithm which we have developed. Say for example, I have my 1 1 2 2 and my 4, 0 1 2 3 and 4, right? So my index is over here, and I'm starting my traversal from my first position. Now I check, is my 1 is greater than its previous? No. So what I will do is I will simply ignore that 1, so I will go ahead, that is I will come at this position, that is at index 2, right? Now we'll check, is my 2 greater than its previous? Yes. So I need to insert this 2, I need to insert this 2 at position this, right? No, sorry, my index initially will be the 1, because we have already tested that value, we need it. So my index will be pointing to my first location, right? Is my 2 greater than its previous? Yes. So simply what we need to do is we need to simply put here 2 and take my pointer to the next position, that is over here. Now come at here 2, is my 2 greater than its previous? No, ignore this. Then I come at 4, is my 4 greater than its previous? Yes, this is true. But the point is I need to put this 4 at this location, at this location. This 4 should come at this location. How can I put over there? This is the reason why I use the index. This is the reason why I use the index. So simply what I will do is at index position my 4 will come here and my index will be shifted to the next position, but we came out of the array. So this is my final answer. Now the question comes, hey Pramod, we already removed the duplicate, but the point is there are still 2 elements present in my array. So what I need to return? Do I need to return whole array, or do I need to return the index where my final element has been inserted? So the answer is we need to return the index, that is the final index where it has come while inserting the element. Now finally my 4 is inserted at index 2 and my index has moved to 3. So I need to return index. So my value of index will be 3, and we need to traverse our first 3 elements which are non-duplicates. So I hope so you understand this question. Now if you talk about its time complexity, it's simple, it is big O of n. And what about the space complexity? Big O of 1, because we haven't used any extra space. So I hope so you understand the clear explanation of this part. Now we will see the coding part on the Leetcode. Now let's see the coding part of this question. So before moving to the coding, let's discuss one thing over here. I have declared index equals to 0. But in explanation part, I told you that we can omit the index 0. We can directly start from index 1. But why I wrote here index equals to 0? So there is no any different thing I did over here. I also managed that thing using this condition inside the if. So what does it says that not of index means index should not be 0. Index should not be 0, which means anyhow we are ignoring the element present at my first index. Because if you don't ignore this element, what we are trying to check is this element greater than its previous? But the point is there is no any previous element. I hope so you got me. Alright, now let's traverse dry run this algorithm. So what I am trying to do is initially I am at index 0, and I am checking. So not of 0, so it would be true, right? So this condition gets true, and since it is OR, we don't need to check my second condition. So here it will be 1, and my index will be shifted to as equals to 1. Right, now again I will come over here I will check, is my 1, now this condition will get false, right, because it is not equals to 0. This condition gets false because 1 of not means 0. Now this condition gets false, we will come here. Now I will check, is my 1 greater than its previous? This condition gets false, hence we simply ignore it. Then we come over here, then I check, is my 3 greater than 1? Of course yes. So I will simply put over here, right? We will simply put in this, that is index. Let me erase this first. So here we will be having a 3, so here we will be having a 3, and my index will be shifted to the next position, that is at 3. Now again I will come over here. Now I will check, is my 3 greater than its previous? No. Then I will come at 4. Is my 4 greater than its previous? Of course yes. Now I need to put 4, but where I will put? At index 2, because my index is pointing at this position. So I will simply point over here. So this will be a 4. Now I come at 5. Is my, and my index will be shifted to next position as usual. Then I will come at 5. Now then I will check, is my 5 greater than its previous? Is my 5 greater than its previous? Of course yes. So I need to put this 5 at an index 3. So where it is my index 3? So index 3 is over here. So I will put it here. Now again my index will be shifted to 4, right? But I don't have any elements. So what I'm returning is, I'm returning the index, that is 4. I need to traverse my first 4 elements, that is this. I need to traverse these first 4 elements which are non-duplicates, and also they are in sorted form 1, 3, 4, 5. I hope so you understand this question. If you really like the way I'm teaching you, do subscribe the Runtime Error. Till then, have a happy coding.